sometimes you have angles that you want to look for. If you're doing real work in real life, and if you're doing even if you're doing a little geometry, you want to know. Sometimes you want to know the measure of an angle, and a lot of times it's based on information that you already have. And one of the most common stuff we do in people doing geometry is give you a parallel line and a transversal. And in this problem, we're gonna do something similar, but there's a little bit of trick added to it. So we have two parallel lines here, a transversal going this way and a transversal going that way. But it really this is an isosceles triangle. Let me show you exactly what they mean, what they ask us here. So it says in the following figure, MN with the segment and MN, which is the top one, and PQ are parallel. Point A lies on MN, a point B and C lies on PQ. If AB and AC, if AB is equal to AC, an angle MAB has a measure of 55 degrees, as shown in the figure, what is the measure of ACB? So what they want us to calculate is angle ACB. So this angle ACB, which is this angle right here. So this is what we don't know. This angle right here is called X. All right. So first they tell us that this line here is parallel to this line. The second thing they tell us is this is equal to this. So these two segments are equal. What makes the triangle ABC is an isosceles triangle. ABC isosceles. ABC is an isosceles triangle. Isosceles triangle. So what does that mean? ABC is an isosceles triangle with AB is equal to AC. So that means the angle here and the angle here are the same thing. So ABC, angle ABC is equal to angle ACB. Angle ACB. B, not a D. All right, so I haven't really done anything here. So all I did is just saying, okay, I know this is a triangle, isosceles triangle. I know this angle here, ABC, is equal to ACD. So now what else do we know? So how do we find the angle here? So there's a theorem that says if we have a parallel and a transversal, the alternate interior angles are equal. So alternate means one side of the transversal and one on the other side of the transversal. Interior means in between the parallel. So alternate one on one side of the transversal and then one on the other side of the transversal, but interior. So let me show you what this means here. So that means the alternate. So if we take this transversal in consideration, right? Man, that don't look like a line at all. So if we take this transversal in consideration, a little bit better, alternate angle would be the angle here that is 55, and what is it alternate to? So something on the opposite side of the transversal. Alternate, one side, the opposite side, alternate. So that means it's equal to the angle, this angle A. Let's call the angle, this angle ABC. So that means angle MAB, angle MAB, let me blur this, is equal to angle ABC, angle ABC. That's just a theorem that says alternate interior angle are equal. So angle M, they alternate because they each one are on the opposites, on this side of the transversal, on that side of the transversal. Angle MAB, which is this angle, and angle ABC, which is this angle. Interior, that means they in between the parallel. So if it was exterior, it would be somewhere here, outside of the parallel. Interior, in between the parallel. So angle MAB is equal to angle ABC, Where else do we see angle ABC? Here, because we have an isosceles triangle. Angle ABC is equal to angle ACB. So that means this angle is equal to this angle, which is equal to this angle. So that means 55, which is MAB, is equal to 55 degrees is equal to angle ABC, which is equal to, according to the isosceles triangle, which is equal to angle ACB, which we call X in this case. So that means X, which is angle ACB, is equal to 55 degrees. And that's it. That's all we could do in this one. All right, let me show you what the answer is. I think we answer, yeah, G is the answer here. So if you enjoyed this video, please share it on your page, share it anywhere that you can. You'll help a lot of kids taking the ACT and the SAT. Again, this is Romel with the Jax Tutor. Thank you very much, and you have a good one. Thanks. Bye.